Solve the following differential equation by using integrating factors. So how do we do that? Here's the steps. Step one, get dy dx or y prime alone, then the y term, then the other stuff. So let's do that. Step number one. So we got to take this y term, move it over. So we have x y prime minus y equals negative 8x cubed. So that's almost right, but now we've got to remember we've got to get the dy dx or y prime alone. So we got to get rid of that x, don't we? So let's divide through by x, divide through by x, divide through by x, cancels out. So y prime's alone. I'm going to write this 1 over x times y just to separate things. And this will cancel, be minus 8x squared. Okay, so now we've got it in the right form. We got the y prime alone, we got the y term and the other stuff. Okay, so we're ready for step two. Step two, find the integrating factor mu of x is e to the integral of p of x dx. Okay, so step two. So first off, we got to identify what is that p of x? Do you notice p of x is whatever's next to y? That's what we're going to put in the integral up in the power of the e. Whatever's next to y. So I got to identify that. So that would be this. This is p of x. So the mu will equal e to the integral p of x dx. That's e to the integral. What's p of x? I'll put the minus out here. 1 over x dx. That's not bad. We can do that. That's e to the minus natural log of x, isn't it? You know the integral of 1 over x is natural log. And then, do you remember what we can do with the powers then? We can say, oh, that's e to the what? That's really a minus 1 times the natural log of x. And then that minus 1 can go up and become the power. Remember, that's a pre-calculus, that's a log property, that whenever you have numbers multiplying the front of a log, it can go up and become the power. So that is e to the natural log x to the minus 1. And why is that so great? Because now these cancel. Now that the e and the natural log are right up against each other, they cancel. And so that is just x to the minus 1. So our integrating factor mu, after all that, is just x to the minus 1. Simplified quite a bit. Okay, now that's step two. Now, on step three, we're going to multiply the differential equation by that integrating factor. All three terms of the differential equation by that integrating factor. So let me bring down, here's the differential equation. Let's bring it down. So y prime minus 1 over xy equals minus x squared. I'm going to take that integrating factor right there. Here, maybe I'll change the color. And I'm going to multiply that. So I'm going to go x to the minus 1 there. I'm going to make it 1 over x. It's the same thing. I'll say or, right? It's the same thing. So I'm going to put it there, put it there, and I'm going to go there. We put it in all three spots. Got to multiply through the whole equation by it. Now, what's going to happen? On the left side, this is going to become y prime x. You can make it 1 over x if you want, whatever. Yeah, you could just make all those just 1 over x. That'd probably be easier. How about I'll just do that? Whatever. It doesn't really matter. I'm probably wasting too much time here. Anyway, so this will be y times 1 over x. Y prime times 1 over x minus 1 over x squared y, right? Because those guys multiply equals, and this is minus 8x to the first power because this cancels one of these, x to the first power. Okay. Now what? Step 4 says the left side is the derivative of the product of the integrating factor and y, and write it as such, right? d dx of the integrating factor times y. So that's step 4. Let's do that. Step 4. Right. d dx of y and the integrating factor. What was the integrating factor? 1 over x. And the right side hasn't changed. Is that true? Is the derivative of this guy? You don't have to check it, but you can. Verify. Is it going to really go back to that? Yeah, take turns. Remember, it's two things multiplied. Derivative of the first is y prime times the second unchanged plus the first unchanged times what's the root of this? Well, this is x to the minus 1. The minus 1 comes down. It's minus, and then you subtract 1 from the power. Yeah, that's right. Okay, that's a neat trick. Okay, now what? Integrate both sides of the differential equation. Now the magic happens. So now on step 5, we're going to go integrate the left side, integrate the right side of d dx of y times x. This is, I'll make it minus, in fact, I'll just make it minus x dx like that. Now, the magic I was speaking of is right there. Those cancel, don't they? Because an integral and a derivative are opposites of each other. So that's why we wrote the d dx, because we knew we were going to integrate and then cancel that out. So that's a super nice little trick. So this is just y times 1 over x, just drops on down. Now on the right side, that integral, we're going to have to do it. It's not going to cancel because there's not a derivative there to cancel it. There's just an integral, so I've got to do the integral. But that's not a hard integral. This is a 1 power, so add 1, that'll be 2 over 2. So that'll be minus 4x squared. And don't forget, plus a constant whenever you integrate, right? You can double check that's right. If the 2 to be minus 8, subtract 1 from the power minus 8x. Go back to what it was. Okay, we're getting close. Now we're trying to get y alone. That's, we always want y in the end. Try to get y alone. So what are we going to do to get y alone? Well, I'm going to take this y times 1 over x. This minus 4x squared, make that look better, plus a constant, and I'm going to multiply through by x. That'll get y alone, right? By x, do whatever it takes to get y alone. So y alone is minus 4x cubed plus c times x. Now, last thing, we want to find out what that constant is. How do we do that? Plug in y of 1 is 64, like they told us. Y of 1 is 64. So plug in y of 1 is 64. That means when x is 1, so put 1 there, and 1 there, y will come out 64. So that means 64 is minus 4 times 1 cubed plus c times 1. 64 is minus 4 plus c. Add the 4 to both sides. And C is 68. So we got it. So back to here's our equation, but now we know C. So we have y equals, sorry, that's kind of scribbly. Y equals minus 4x cubed plus C, which is 68 times x. There we go. Is that right? Minus 4x cubed plus 68x. Minus 4x cubed plus 68x. We got it. There we go.